Objective 6, explain the trend for melting point down families 1 and 17 and across period 3. Well, down period 1, metals bond by attraction between the nuclei and the delocalized electrons, which are your valence electrons. So down a family, this attraction decreases with the increase in N or size. So that means melting point will decrease. But that's only for metals. Non-metals attract with intermolecular forces, and specifically dispersion forces for when they're Cl2, I2, when they're pure nonmetals. And they arise from temporary dipoles, which means for an instantaneous moment, electrons are shifted more toward one nucleus than the other, and you just very temporarily get this positive area, negative area. But they're totally nonpolar, so these are very temporary dipoles we see. So in that case, we're going to see which increase in occurrence with more electrons. And more electrons anywhere. It doesn't matter if, I didn't have that spelled right, with more electrons in any level. So it will increase, melting point will increase as you move down the family and there's more electrons. Now period 3, that's kind of a hot mess because we've got everything going in period 3. We start with the metals, so it increases across metals as the number of delocalized electrons. Then it really increases with silicon, which forms a giant covalent structure. And when you see that, think of sand, how hard it would be to melt sand, or look one above it to carbon and think about how hard it is to melt diamonds. So those giant covalent structures are very, very strong. And then decreases with the covalent nonmetals, phosphorus, sulfur, chlorine, and really drops for the noble gas of argon.